right, hey guys, I'm going to go over some of the tougher problems that you might see on the Module 2 test. If I were you, I would make a new page in your notebook and title it Module 2 Review, and I would write these problems in your notebook as I go through them so you have these examples for your test tomorrow. All right, so it says Grant Middle School is having a free throw contest, and here's how the kids did. So Jasmine, she got 27 out of 50. Okay, so I'm just going to write that as a fraction. Mark got 14 out of 21, and Arthur got 6 out of 11. And it says, well, let's start with Mark. What's his ratio expressed as a decimal? So Mark was this middle one. Okay, so now you might think, oh, I got to divide this out, which is right. But an easier way to do this is if you guys can simplify first, that is definitely going to help you. Okay, it'll make the numbers way easier. So like 14 and 21, I know 7 goes into both of those. So watch if I divide that out, I end up with 2, and 21 divided by 7 is 3. So now watch this. 2 divided by 3, this is way easier. Okay, so I'm going to just pause and work that out. All right, so it looks like it's 0.6 repeating. Okay, so we have Mark's decimal expressed as or Mark's ratio expressed as a decimal. And I'll just put 0.6 repeating. Okay, now it said which of these students' ratios can be expressed as a terminating decimal? So which one actually ends? Well, to do that, you're going to have to kind of work them out. Now, this one, 6 over 11. Okay, you could just divide that out. But 27 over 50, watch this. I'll just show you a little trick. You could divide that out, or why don't you change that to 100ths? And think, how do I get from 50 to 100? I could double it. Okay, so I could also double 27, which is 54. So 54 hundredths, I know that that is actually 0.54. So that looks like that's a terminating decimal. Again, I could do 6 divided by 11. I would just work that out. That's actually going to be repeating. Now, I'm not going to work that one out. You guys know how to divide decimals. Also, quick reminder, whenever you guys need to pause the video, just pause it so you can write stuff down. All right, the next one is wanting you to change this repeating decimal to a fraction. So remember, here's how we did this one. As soon as you guys see this, you should probably remember. So first thing I do is write it out, 0.72727272. Since there are 2 numbers repeating, I'm going to times both sides by 100. Okay, so I end up with 100x equals, if I times this by 100, it'll be 72.727272. Okay, then if you remember, we're going to take away x from both sides. So I'm going to subtract x. Basically, you're taking away this top line. And then I'm going to subtract 0.7272. Okay, I end up with 99x equals 72. And then one more step, I'm going to divide by 99 on both sides. And I end up with my fraction is 72 over 99. Okay, let's look at this next one. And I'm doing this kind of quick. So I have a square flower bed. So here's a square, and it says the area is 1.96. Basically, I want to know what times what equals 1.96. All right, so on one like this one, you're trying to figure out something times something equals 1.96. Now, you guys have a list of your square roots. Okay, if you look that up, just kind of ignore the decimal. Just kind of think 196. Well, I know 14 times 14 equals 196. So I know it's going to be something with 14. I just have to figure out where the decimal is. Okay, so if I'm going to guess, I'll guess maybe 1.4 times 1.4. Okay, if I work that out, I get 1.96, and then let's look at the decimals. There's one spot here, one spot here. That means I'll move it 2 back, so 1.96. So I know that's correct. So my answer is 1.4 yards. All right, this one can be a little bit tricky. So it says select all the answers that are correct. So let's kind of look at this one. Okay, so it's got the positive and negative sign, and then the square root of 16 over 36. Okay, well, I know it's going to be positive and negative. The square root of 16 is 4. The square root of 36 is 6. Okay, so I'm going to just kind of see which ones I see maybe work out. So I know positive 4, 6 is an answer, so C, and negative 4, 6. Okay, now let's look at the other answers that are there. What if I simplified this fraction? What if I divided it down by 2? I end up with 2/3. Okay, so it's still positive and negative. So it looks like I can add a couple other. I see negative 2/3. Oops, I didn't mean to write it like that. Meant to highlight it. So I see negative 2/3. So that one's a choice. Okay, now my other issue is, there's decimals. It's probably one of these decimals. So I'm just going to have to divide this out. 2 divided by 3. We actually did this one before on a different page. Goes in there 6 times, which is 18. Get that again. Looks like it's 0.6 repeating. So again, and it was positive or negative. So it looks like D also works. Okay, it definitely does not equal 0.333 or 0.444. So there's 4 answers on this one. All right, this next one, definitely put in your notes. This was a hard one on the review you guys did. So it says a concrete path has 3 equal-sized squares arranged in a row. So here's a square, here's a square, here's a square. Pretend they're equal. It says the total area of the path is 75. So that means all 3 of those are 75. I want to know what is the length of the path in feet. That means I want to know how long it is total across the bottom. Okay, so let's think about what we know. Total it's 75. Well, if there's 3 of them, let's do 75 divided by 3 to find the area of each one. Well, 75 divided by 3, that's 25. So that means this square has an area of 25, this one has an area of 25, and so does that one. Okay, well now we better figure out what the side lengths are. So what times what is 25? Well, that's a pretty easy one. 5 times 5. Well, that would be the same for this square. 5, 5, 5. Okay, now the question is, how long is the total length? So how long going all the way across the bottom of this path? Well, I've got 5 and 5 and 5, which is 15 feet. So the path is 15 feet long. All right, this next one, I'm not going to work all the way out, but I will get you started on it. So if it says round to the nearest tenth, remember tenth is 1 decimal spot. Okay, so this one you actually have to do a little bit of work for. So square root of 85, close to it is the square root of 81. That's a perfect square. And the square root of 100. So then the square root of 81 is 9. Square root of 100 is 10. Now, if I asked you to list me a number between 9 and 10, you guys would say like 9.5 or 9.6. So this has to be 9 point something. So that's why I always write the first number. Okay, then to find out the fraction, you figure out what's the total distance. So from here to here, it's 4. From here to here, it is 15. 15 and 4 is 19. Okay, then the top number of the fraction, remember, is always the first. So it was a 4. So it's going to be 4/19. Okay, now you guys know you would now try to turn this to a decimal. So I would do 4 divided by 19. Now I'm not going to do that right now, but I would get 9 point something, and you just need 1 decimal spot. All right, so my next problem deals with a cube. It says they have some cube-shaped bins on their shelf, and the volume of this cube is 475 cubic inches. Okay, and it says the length of each side must be between 7 and 8. Diana thinks it's 7. Gina thinks it's 8. Okay, we want to know, well, which one of them is right? So this is something you're going to want to put down in your notes. The volume of a cube, you do the base, oops, let me erase that. You do the length times the width times the height. So the length times the width times the height. So whatever number they choose, a cube, it all has equal sides too. So if one girl thinks it's 7, you would do 7 times 7 times 7. Okay, the other girl thinks it's 8. Then I would do, okay, 8 times 8 times 8. I want to just see, well, who is closer? Okay, who is correct? Well, if I do 7 times 7 times 7, you guys can use your perfect cube chart. Your cube roots, it's 343. Again, you have this in your notes. 8 times 8 times 8. Oops, I'm just typing it in. I think it is 512. So we want to know, well, who's a little bit closer for the volume? Well, to me, 475, that looks a little closer to 512. So the girl who chose 8, I think it's Gina, she's a little bit closer. Definitely make sure you have this one in your notes. All right, so this next one, it says the floor of a playpen has an area of 5. Okay, I want to know, well, what is the perimeter of that playpen? Okay, so let's think about this. We know something times something has to be 5. Well, to figure that out, we would have to do the square root of 5. Now, we're rounding to the nearest integer, which is kind of nice. So think, well, what's close to the square root of 5? All right, well, square root of 4, square root of 9. That answers 2. That answers 3. Now, if I'm rounding to the nearest integer, I just want to see what's it closer to. Well, 5 is definitely closer to 4. So I'm going to estimate it's about 2 on each side. Okay, so 2, 2, 2, 2, because it's a square. Now if I want the perimeter, perimeter means add all the way around the outside. So I would do 2 plus 2 plus 2 plus 2, and I get 8 for the perimeter. Okay, so be careful. It says round to the nearest integer. That means you don't need a decimal, and it was way closer to the square root of 4, and the answer to that is 2. All right, I want you to pause the video, and I want you to read through this question and think about what do you think you would do to solve it. All right, so it says I have 2 pendulums in a museum, and they're going to swing back and forth, back and forth. And it says how many more swings can pendulum 1 make than pendulum 2 every minute? And it says round to the nearest whole number. So that's kind of nice. We're rounding to the nearest whole number. So let's start with the formula they give us. It says 375 divided by the square root of the length. Let's start with pendulum 1. Okay, well, I know it's 38 inches. So instead of an L, I'm going to put a 38. Okay, so my next step is I'm going to actually try to see what is the square root of 38 about. Okay, so I'm going to come down here and I'm going to say, okay, square root of 38, and what's close to it? Well, 36, 49. Again, you guys have those in your notes. Well, the square root of 36 is 6. Square root of 49 is 7. Okay, well, 38 is definitely pretty close to 36. So I'm going to say it's about 6 because it's set to the nearest integer. So this one is 375 divided by 6. Okay, now the one on the test will be pretty nice, but you're going to divide that out. So I'm just going to use a calculator for this one just because, just for time's sake. So if you would divide that out, 375 divided by 6, it's actually about 62.5 or about 63. Okay, now I'm going to do pendulum 2, and I'm going to do that in a different color. So pendulum 2, I'm going to do 375 divided by the square root of 49. Well, this is kind of nice. The square root of 49 is 7, and this is 375. So now this time I'm going to do the square root of 375, or no, I'm just going to do 375 divided by 7. Again, you guys could work that out on the test. You would just do 375 divided by 7. Okay, for time's sake, I'm just going to divide it out here, just because I don't want this video to be too long. So 375 divided by 7, it's about 53.6. Okay, so that's about 54 if I round to the nearest whole number. Okay, so now let's see if we can answer the question. It says, how many more swings can pendulum 1 do than pendulum 2? Well, one of them does 63, the other does 54. To see how many more, I'm going to subtract. I'm going to do 63, take away 54, which ends up being 9. So it can do about 9 more swings. So there are a lot of steps in this problem. Again, this would be one I would want to kind of write down so you have a good example of how did I get everything here. All right, the last thing, I just want to refresh your memory quick, and you guys make sure you look at your notes. Most numbers that we work with are rational. So like normal numbers, positives, negatives, fractions, decimals, repeating decimals, percents, nice square roots like the square root of 25, the cube root of 27, because they work out nice. Those are all rational. 0, those are all rational numbers. Irrational, there's not that many of them. Okay, one is pi. The other ones are like the not nice square roots, like the square root of 14 or the cube root of 13. Those don't work out nice. Or if you get a decimal, like 4.76234127 that never ends and never repeats, it's irrational. And then the only other one is if you have 0 on the bottom. Okay, so again, most numbers are rational, just the ones kind of like the not nice square roots, the not nice cube roots.